all elements of your, I can't say G because it's going to be confusing, right? In this context, the kernel is the subset, all of whose values map to the unit, right? So we're trying to, now your starting group are the integers, right? Here, that's your starting group. So what integers give you E here, right? Remember the kernel maps to the unit of your target group. Now the target group here is G, big G, right? So what is its unit? Well, just little e, the unit of this group. So what values of n here, the subset of them, that give you, where a to the n gives you e? Well, this element here has finite order of n, let's say. So when this integer is n, that's sort of confusing. Let me something like that, because that's just an arbitrary, and it's just any number. So I'll change it to distinguish it. So let's say this element has order. The element has order big N, right? So what integers here will give me a to the n just equal to e? Well, if it's order n, big N, that will give, if I have big N here, that will give me e. If I put 2n, big N, 2 big N here, that will also give me e. And if I, so in effect, the values that give me f equals e here, those values will be 0, plus or minus big N, plus or minus 2 big N, plus or minus 3 big N, and so on. In other words, the multiples of n, big N. So the kernel is just the set of all of those. Well, that's just nz, right? That's all possible multiples of n, plus or minus. Okay, so the kernel is then just big N z, right? All right. Now we want a surjective mapping. Perhaps I should have emphasized that before. Yeah. This f here is supposed to be surjective in each case. I haven't explicitly said that in the others, but this f needs to be surjective, right? It doesn't have any elements in the target group that are loners, that are not mapped to. Right? Every element of your target group is mapped to. All right. So let's say G is cyclic. What does that imply? So if G is cyclic, it means that every element of G can be expressed as some power of a generator, right? So so we can find, what is A? It's just any A? Cyclic. That's not clear actually from the text. Well, I'll throw that. I need to think a little myself. I'll throw that out as a challenge too. Show that if G is cyclic, if this group G, the one that you map to, the target group, if it's cyclic, show that this this mapping F here is surjective. And the question mark I'm having is, how do you know that this A here is the generator? What if it's not? That's my question mark at the moment. So anyway, think about it. All right. And here's another one you can think about as well. if G is infinitely cyclic, then G is just isomorphic to the integers. So have a think about that. Why is that the case? And if G is cyclic, just finite, ordinary cyclic, finite cyclic, and the order of the group, not the order of the element, but if the order of the group is of order n, then we can use this first isomorphism theorem to say, now this G here is what? It is, we've found, this example is definitely tougher than the others. So we need to say that that's the image. Why is G the image? If G is cyclic. So every possible value of f is one of these elements. Okay? Now if G is cyclic, okay, now I understand. That wasn't spelled out in the text. Okay, so we're assuming G is cyclic, right? That means that every element in that group can be expressed as some power of the generator. But again, I'm left with the question, why should A be the generator? So it's the same question I'm having, right? So there are some loose ends in this example. Well, assuming this is a generator, then every possible value you can get of f will be of this form. And this can only take on big N different values, right? Because big N is the size, is the order of your group G. So the set of those is just your group, right? Because groups G is cyclic, and if little a is the generator, then there are only big N possible values, different values you can have for this, and that's the group. Those elements are the group, right? So your image then, your image of your f would be, all possible values here, and that's your group. So that G there, big G here, that's your image of f. In fact, what they've done here in the text is they've just switched this around. It doesn't make any difference. You're talking about isomorphism. Okay, so the image is isomorphic to your original group. Now I can't call it G because that's confusing, because big G here is now the target group. So your starting group, which is this one, integers, right? That's your starting group slash, and this is your kernel, right? And what is the kernel? What is the kernel? Did we talk about that? Here. Yeah. So here's your kernel, just big N of Z. So just plug it in here, right? And there you've got your fourth relation, your fourth example of first isomorphism theorem. Right? Well, that's the 4 examples. The next session, because I've run out of board, will be problem solving. And at the end of that, I'll make some general comments, because this is the end of the course, right? And it's not only the end of this course, it's the end of the very first course in the whole series of, if I don't get run over by a bus tomorrow, it will be the end of the first course or lecture set in this whole series of deGarisMPC. And I'm hoping over the years and decades, if I can live long enough, stay healthy enough, that there may be hundreds, many hundreds. Depends on the rate that I can churn them out. I'm somewhat constrained by upload times to YouTube. I'm constantly looking for solutions. People are starting to send in to me now suggestions on how to, for example, compress the movie file, the video file, so that it's much shorter, and perhaps even do that where the original filming is in high definition, HD. That would be great. Then you could see this board more clearly. But I'm learning, trial and error, I'm learning that by doing this in the daytime, it seems to have a better effect. It's clearer. It seems the daylight has a better effect on the camera image than night light. So I may keep doing this during the daytime, which means I may need to become a day person rather than a night person. I can do whatever I like, right? I'm an archer after retirement career, so I'm totally free. I just do what I like, what I want. So I could do that. I could become a day person again. Right. So next session will be problem solving, and it will be the last of this whole lecture set, this whole course.